So we're very happy to introduce the next set of speakers. Marco from Cisco CX and Paolo, who was up earlier, I believe, right? A repeat customer. And they're going to talk about streamlining network upgrades at Telecom Italia.
Yeah.
So thank you, guys.
Thank you. Thank you, everybody. I'm Marco. I've been working with Cisco for 2 years and a month, more or less, so I still feel like the new kid in town, especially here at Developer Days. It's the first time for me, so I feel pretty excited and proud to be part of this. So, having said that, let's start this presentation. So, today we're going to talk about a specific network migration use case, and in particular the automation of such use case, we developed in collaboration with Telecom Italia, with Tim, in the context of, I would say, Paolo, a big network upgrade initiatives at Telecom Italia. For this reason, Paolo was so kind to join us on stage. He's going to give us a little background about the project. Then I will take it from there. We're going to talk about how we automated this use case. I'm going to give you a little bit of design details. Then I will show you how we implemented everything. And I will recap everything with a quick live demo and the usual conclusion section. So without further ado, I'll hand it over to Paolo.
Thank you, Marco. So for those who were here this morning during my speech, this is one of the most challenging automation use case we implemented a long time. And just to give a bit of context, it comes from the need we had to develop a big multi-year project aiming at distributing IP in the periphery of our network. We have to put IP routers on more than 3,000 sites, and we managed, first of all, to make the zero configuration of these routers. But then, after the zero configuration, the major point was to migrate customers before connected to more centralized location to this more distributed location. So to migrate customer accesses from centralized to distributed location. The name of the project was Revolution, for its impact. And why we did? We did to try to optimize network architecture and improve the TCO of the network, reduce the cost, especially of optical transport, and enhance the capillarity of the IP network. So this is a very schematic view of our metro regional network. We have a few tens of major national POPs, which are collecting a few hundreds of intermediate nodes that were the most peripheral nodes we had. Then we added this further layer with few thousand, I said 3,000 and something. And then we need to move all the access lines from the few hundredths level to the few thousandths level. The name of this new level of equipment is local aggregator in our terminology. And we have to move access nodes such as OLTs, DSLAMs, and so on, but also mobile access nodes for 4G and 5G. So the scope of the project, the requirements is to deal with more or less 10K interfaces within the team network, having for each physical interface up to 1,000 services already configured. We need to have an execution time of the migration in the order of a small digit of hours, and also the need to implement it in such a way that is not impacting the services for the customers. We have operation distributed in the countryside, so up to 8 different migration can happen every day with some degrees of contemporaneity. And execution of the other activities done on the automation platform, such as service delivery or other stuff, should be preserved. So that's all. I give the floor to Marco, and I have to cheers you because you have to be in another room.
Thank you, Paolo.
Okay.
Thank you. Okay, so let's talk about this migration activity. No automation yet. Let's talk about how Telecom Italia sees this activity. So it's, first of all, most important thing to say, it's a multi-stage activity. It complicates a little bit what we want to automate. So it consists of a set of stages. The first stage, basically, we prepare the new link between the local aggregator and the access node. Of course, we don't swap the cable yet, but we prepare everything. Once we have prepared this new link, we go to stage 2, actually it's 1B, but it's the same. We go back to the feeder. I remind you, the local aggregator is the destination, so it's the new attachment point. The feeder is the old attachment point. So we go back to the feeder, and we discover all the service instances that we want to migrate. Now, with the new link prepared, let's say, and on the list of services, I mean, Telecom Italia, is able to prepare what is called the master plan document, which is basically a document describing the migration activity. Then we go to stage 2, and we configure primary and backup connectivity for all instance services in the master plan. It means that we move the primary connectivity configuration to the local aggregator, but we keep a backup configuration to the feeder. Now, we are ready to actually swap the cable, to connect the access node to the new attachment point, and then we get to the final stage in which we clean up what is now useless because it's not used anymore. What services are we talking about when we say we want to migrate services? What are the service landscapes? So initially, that's another complication, we mainly had 2 types of services. Layer 3 VPNs for mobile backhauling, and Layer 2 pseudo-wires for fixed access nodes, and pseudo-wires for dedicated business or wholesale customers. Okay, that's fine. But here's another problem of this project. The project time frame is actually still ongoing, quite long, more than 3 years. It means that new service models were introduced during the project. And of course, initially, we found only a few units. So it was kind of reasonable to migrate these few units manually, let's say. But then the number significantly increased during the project lifetime. And I want you to remember this aspect. It's not the only complication, but it's one of the complications. Now I want to go back to the example. I want to put everything I said before in a more concrete fashion. And I want you to look at this reference example. So we are now considering a point-to-point layer 2 VPN. This might look simple, but it's realistic. Basically, it's the topology, it's the reference topology. We have the access node. The access node is connected to the feeder. In this case, again, we're considering a point-to-point layer 2 VPN. So we have the configuration on the feeder, which is, again, I remind you, is the old attachment. And an L2 VPN service basically consists of 2 sections. One regarding the interface. In this example, it's just the directive interface, but of course, you can imagine we have other stuff under that CDB node. And then we have the L2 VPN Xcarnet group, the P2P group, in which we have the same interface that we have above. And of course, we have a neighbor toward the apps. Now, this service, of course, it's also the counterpart configuration on the hub, which is pretty similar. Of course, the neighbor is pointing to the feeder. OK, this is the service we want to migrate. What it means that we want to move the access node from the feeder to the local aggregator. By the way, I just want you to note that also the main interface is changing the number, of course. And we want to update the configurations according to this network upgrade, let's say. So, stage 1, pre-migration. If you remember, we create primary and backup configuration. So what does it mean? It means that we go to the feeder, to the hub, sorry. We remove the previous neighbor, which was pointing to the feeder, was the primary neighbor, of course. We create a new primary neighbor toward the local aggregator, but we also create a backup neighbor toward the feeder. On the feeder, we don't do anything, of course, but we go to the local aggregator, and now we create this service on the local aggregator. And if you look at that little piece of configuration, you see that it's actually exactly the same configuration we had on the feeder with a few parameters changed. Now we can go to stage 2, and we can actually swap the cable, which means that we attach the access node to the local aggregator. With this particular type of services, we don't do anything, but for other services, we have to do something in the stage. But now we physically move the cable. So at this point, the backup configuration is useless because nobody's there. The VPN is not transported by that backup cello wire. We can clean up everything. What does it mean, cleaning up? On the local aggregator, nothing, of course. The service is ready. On the hub, it means we remove the backup neighbor. Again, it's useless. And on the feeder, we remove almost everything. We delete the interface, we delete the P2P group. Of course, if the Xconnect group does not add any other P2P groups, we remove also the Xconnect groups. And in the end, we get to the final scenario. OK, so how do we do it? OK, so the ideal approach, of course, when you have to handle NSO services would be probably to do it in a stateful way. And the initial assumption was that all the services that we wanted to migrate were provisioned via NSO. We were a little optimistic, let's say. We thought we were in a real nice scenario where everything was in sync, but apparently this is one of our wildest dreams, to have everything in sync. So it's not the reality. And in fact, if this were the reality, the use case would have been really simple. I wouldn't even be here, probably, because we could have used a stateful approach, which means we discover all the service instances, we update the service parameters, we redeploy the service, and done. What does it mean? It means something like this. We have all our service models inside NSO. Of course, this resembles the same example as before. Okay, of course, it's simplified for sake of clarity, this presentation. We have a list of service instances, and we have our master plan. We upload the master plan. We understand that we want to migrate from feeder main interface 000 to local aggregator main interface 333. Okay, it's easy. I do a service discovery. I found out that I have an L2 VPN with ID 100 under that main interface. I know how the model is. I know what parameter I can change the parameters. Redeploy service, I commit, and it's done. Yes. This was actually how we did it the first time. But there's always a but in this kind of presentations. We don't live in a perfect world. We already mentioned that. And the first migration campaigns was something like 1 year, something like that. We found out that this approach had several issues. First of all, we had very, very long service discovery reconciliation phase. Why? We also heard the previous presentation. Because basically, we were doing something a little bit more complicated. It wasn't just about finding service instances. It was more complicated because new services were introduced. It means that we use the same stateful approach for services that were not modeled on NSO. So we tried to model that services in order to use the same approach, the same stateful approach. But this is not service discovery. This is a very complex inspection phase in which you try to map what you have on your device to a service model that wasn't even modeled with the engineering team, but was done just for the migration. And that was really hard because of two things. First of all, brownfield scenario, a lot of OSSs in the big picture, a lot of irreconcilable out-of-band changes. In the end, we also had another problem. A significant number of services were provisioned manually. So this inspection phase was long. Sometimes they started with the inspection, and they complete the migration the day after. And this is not really great for an activity that should be automated. And what are the consequences? We have other services. The problem is that we received frequent support requests during the migration activities, not good for something that should be automatic. And even worse, at the end, we still had a significant number of services that required manual migration. But now I want you to think about this. This is something that happened really in Telecom Italia. They introduced this new flavor of service, same L2 VPN services, but they just wanted to have a static MPLS label association. And now I ask you, but do we really need to model this if the object is only to migrate this configuration? No, You can say that about my tone. And that got us to a point in which I believe everybody here has to do something. So, you know, you tend to get emotionally attached to what you design and what you work for years. But then in the end, it's probably the best moment to rethink a little bit the approach. And the point is, but do we really want to do it in a stateful fashion? And this is true not only for services that are manually provisioned, let's say, but also for services that are managed by NSO, but are, let's say, corrupted by out-of-band changes. It works for both scenarios. And that's exactly why we came out with this service-blind approach, which we internally call stateless approach, but I wanted a cooler name for this presentation. So I will use these two terms interchangeably. So what does it mean? Service-blind approach. Basically, we don't care about the service instances. We migrate the services with low-level, let's say, CDB adaptation and modification. And this is really cool because it doesn't mean that we are not doing it with NSO. We still want NSO, of course. We want all the cool stuff about NSO. But the problem is that we don't need that long inspection phase in order to understand what is the service model to migrate the service. We just understand what to do with that kind of service, and we manipulate the CDB, and we migrate the service. And this does not only solve the problem of services without NSO models, it also supports services that are modeled on NSO, but again, are corrupted because mainly of out-of-band changes. And another aspect really interesting about this approach is that it's fully interoperable with the stateful approach. It means that it can be seen as the best approach when you don't have a service model, but it can also be seen as a fallback mechanism for services that have service models inside the NSO. So, how does it work? So, basically, in order to approach this problem in a stateless way, we need a new stage that was not in the stateful approach. This stage is called categorization. Why? Because, of course, we don't know what is the service model associated to the service. We might even, the service model wouldn't be here, wouldn't be there. It's not there, sorry. So we need to categorize the service. What service do we need to migrate? But this is an important aspect. Categorizing a service doesn't mean that we have to respect all the constraints that we usually have in the service model. Before they said, we are really, I don't remember, hospitality, you know? We have a lot of flavors of services, you know? But in the end, when you want to migrate this kind of services, probably you do always the same thing I showed you in the reference example. So here, for example, I don't want to understand if that service is the particular flavor for, I don't know, business customers of residents. I don't care. I just want to move the P2P group to the new destination. OK, so in the stage, we categorize the service. So for example, here we understand that this is an XR configuration. This is an L2 VPN P2P service. Then we adapt the configuration. Again, we have two different approaches. If you're moving a configuration from, for example, an XR router to another XR router, we use simply the magic API, we just manipulate the CDB. Of course, if we change the technology, it's easier to use templates, let's say. We call them cross-technology templates. But the point is the same. We push the configuration into the CDB without using service instances. Of course, we need to change the parameters, we need to apply transaction, and everything is done. Benefits. Yeah, first of all, we don't have that very, very long inspection phase at the beginning. Second, we support out-of-band changes and manually provisioned services. And of course, last thing, it's also important, believe me, if you have to customize something, if you have new service flavor, it's much faster to add a few Python lines of code into the logic inside the application than remodel everything, verify that the model is correct, and stuff like that. OK. A little bit of implementation. This is a developer conference, so I thought it would be interesting to talk about implementation. Of course, we have an NSO package, which is called after the Team Revolution activity. It's called Revolution. This service model blind approach, the stateless approach, was introduced in a newer version of the package. The new features are fully interoperable with the legacy stateful approach, but this presentation does not talk anymore about the stateful approach. Now, let's focus on the stateless approach. Everything is written inside Action Handler in Python. The application is currently running on NSO 6.1, and everything is well integrated with other components that, again, are outside the scope of this presentation, in particular the GUI and the workflow manager. Of course, we also have a workflow manager. So, migration master plan. This is the first step, if you remember. We need to upload this master plan. I will show you how a master plan looks like, not now. But this is basically an Excel spreadsheet with 3 main sections. We have current attachment, so some data regarding the feeder. The access device, so the node that we want to move. And the new attachment, the local aggregator. The master plan is uploaded via a GUI and parsed into a Revolution service instance. Not the service instance that we want to migrate, a service instance representing the migration, let me be precise. Of course, the master plan is compliant with Telecom Italia terminologies and thermal standards. And this is our master plan. This is the current attachment. We have locality. This is our whole internal inventory nomenclature for Telecom Italia. We have the name of the node. We have something regarding the physical port. We have, of course, to translate the format. But this is important. As you can see, we have multiple rows. And this is another complication. It means then when we want to migrate a node, we might actually have multiple access nodes in the same migration. And this migration needs to be executed in parallel. Access device. The access device is not really touched by the migration, but it's important to understand the type of the access device. As Paolo said, we have different types. We can have OLTs, LTE antennas, 5G antenna, multi-standard antennas, and also this one. And this is the last section. It describes the new attachment. So again, the local aggregator. Again, we have the name, we have some inventory stuff, and Teams internal, the new port, the new attachment port, and so on. Okay, so we upload the master plan, and after uploading the master, after parsing the master plan, of course, we trigger a light stateless service discovery. This is used to gather the list of sub-interfaces that we need to categorize. That's the point. It's not a real inspection. We don't care. We don't want to match, service models with piece of configurations in the router. We just want to understand how to migrate the service. And so we simply need the list of sub-interfaces that we need to categorize. That's the point. Let me tell you something else. The Revolution use case, of course, leverages another big package, let's say, which is called the Inspection Framework. Again, this is outside the scope of this presentation, but this is a package developed by our team for Telecom Italia. Okay, so what does it mean to parse a master plan into a Revolution service instance? Adapt what we have in the Excel to the Revolution data model which is there. It's pretty simple. We have a container named Revolution. We have a list of migration, so which master plan is a migration. We have a list of access devices, the rows in the Excel file. We have the description of the source, the feeder, the destination, local aggregator. And look at the last part, the last container migration. We have a list of stateless services. They are indexed by the ID of the sub-interface, which most of the time is equal to the VLAN, but it's not granted that. And then we have a category, a status, and a service parameters. The status can be migrated, cable swapped, clean, okay? It's to allow a workflow manager to understand what's going on. And these are the categories that we support in our stateless migration tool. We have L2 VPNs, L2 VPN static, the ones with the static mapping, VPLS, L3, multicast, local connect, L3 eVPN, and filtered service, which is a special category we filter. Service parameters is a container that changes according to the specific category, and it's used to store operational data that we discover during the categorization phase. Why? Because, of course, if we need to categorize a service, we are traversing the CDB through different expat queries. So, but since we are there and we need this data, let's store the data that we see when we do the expat queries. That's the point. How do we start a categorization? I told you before, everything is done with actions. So we have a start categorization stateless action. It's a little simplified. The prototype is a little more complicated, but it's not important for this presentation. We use MAPI flags to control the commit behavior. We have a timeout, again, to control timeout. But that's the most important thing. We have a list of sub-interfaces that we want to categorize. And then in output, we give a Boolean, success, and a message. Nothing crazy. So with that action, we trigger the categorization. It means that we want to do two things. Categorize the service, meaning assigning a label to the service to understand what to do, but also extract the parameters, as I told you before. So for example, in that L2 VPN reference example, we want to extract the name of the P2P group, the IP address of the neighbor, stuff like that, the PV class, and so on. Categorization is done with expat queries, of course. These are two examples, but I have prepared our decision graph just to show you how it works. So we start. Is this a multicast service? So let's see. Do I have the interface I want to categorize under a multicast routing group? Yes, okay, it's a multicast service. I extract the parameters, and that's all. No, the interface is not under a multicast group. Okay, I move on in my decision tree. I execute a P2P expat query. It means, is the sub-interface I want to categorize, or better, is the service associated to the sub-interface that I want to categorize in a P2P group? Yes or no? If it is under a P2P group, we're not sure about the service yet, because it might be, for example, a static MPLS L2 VPN service, or a normal L2 VPN service, or can be a local connect. And again, how do I decide that? Because I've extracted a set of parameters. For example, if under the P2P group there is a neighbor, it can be a local connect, of course. But if instead we have two interfaces under the PTP group, of course, this is a local connect, and so on. It's not an L2 VPN or something related to a P2P. We move on with our decision tree. We try to understand if the sub-interface is under a bridge domain, and we do more or less the same. And in the end, we understand what is the category. And again, with the category, we know how to migrate the service. Now, once the service is categorized, we can move to the stages that I showed you before. We have three main stages, plus one that is optional. We have the pre-migration, cable swap, and clean. And of course, we also created a rollback phase if something goes wrong. The configurations are updated, as I told you before, for same technology migration with just manipulating the CDB, with magic copies. But if we are changing the technology, it's easier to use cross-technology templates. These are the interfaces for the actions that we developed. Of course, start migration stateless. For the pre-migration, start cable swap stateless, and start rollback. They have the same prototype. Basically, you give them a list of sub-interfaces, again, timeout, mapping flags, you get the same output. The clean is a little bit more complicated because unfortunately, especially for L3 services, if you clean something, you need to clean everything that is under the interface. So if we have multiple access nodes, because there is an aggregator behind the feeder, you have to wait for all the access nodes to be cleaned, and then you can clean everything. But this is a detail we don't care about. Now, it would be really nice to talk to you about all the challenges that we faced for implementing this use case, but of course, there's not much time. I want to just show you the skeleton of all the actions that we developed. So, first line, we basically create this object, status migration. We parse the migration instance. We understand what we have to do. We do some initialization and stuff like that. Then we open a parent transaction. The parent transaction is used to commit the whole bucket, because this is important. When we migrate services, we don't migrate one service per time, you know. We get a bucket from the workflow manager, I don't know, 20, 30, 40, I don't remember, it's configurable. Services that we want to do all together. But now we have a problem. I told you that we are manipulating the CDB at a low level. We don't know if we can get exceptions. We can get exception everywhere. Okay, if the exception is related to the first service, okay, you just get rid of the parent transaction, you open a new one, and then you go on. But let's say it's the third service that has something wrong, and you have already did something, you cannot revert only the last two things that you've changed in the CDB. So after talking with the BU, we said, okay, the best approach is to use transaction in transaction. It's interesting. So basically, we loop through all the sub-interfaces that we have, and we open a child transaction for each sub-interface, so for each service that we want to migrate. And as you can see, we have a try except block there. If we get any exception everywhere while processing that sub-interface, we simply skip the child transaction. Otherwise, we commit the child transaction into the parent transaction. At the end, we will have a parent transaction with all the services that we are able to migrate because we didn't get any exception. Then we also save the commit queue item because we might have timeouts, but this would take me, I don't know, a few minutes to explain, so this is not important. In the end, if everything goes well, we simply reply, we get a nice Boolean true, everything went fine, and a message. And that's the skeleton. Demo. So I said a lot of things. I thought it would be nice to give you a demo to recap everything, and let me talk to you a little bit about the demo. So I've prepared a Docker environment here on my laptop. I have an NSO on Docker. Of course, I'm using NetSim devices. I only have these devices because it's a simple demo, of course. We have a feeder, we have a hub, we have a local aggregator. And we want to move the services from the feeder to the local aggregator. This is the Revolution instance. So you can imagine this as the stage after we upload the master plan. So we upload the master plan, and that's what we get into NSO. We have this migration called DevDay demo. Only one access device, type is alt. As you can see, we have 3 stateless services. I told you we're not talking about the stateful approach, but in a real world, we would also have the stateful services there, but we don't care for this presentation. And basically, we have 3 services under the sub-interfaces 22, 170, and 3578, where on the feeder XR, source port is 10 gigabit Ethernet 0703, and we want to move everything to the main interface 0001 of the local aggregator. LAXR. This is the scenario. These are the services. So this is a layer 2 VPN service under sub-IF 22. It's more or less the same reference example I showed you before, but as I already told you, we have a bunch of lines under the sub-interface. First directive there. The VPN2 part is exactly the same. Of course, this is on the feeder. We have something similar on the hub. Of course, another sub-interface, but we don't touch that interface. And we have the P2P group there. Of course, the pseudo wire is pointing to the IP address of the feeder. But we also have 2 other services. We have a local connect service. Local connect looks a lot like an L2 VPN, but what's the difference? We don't have a neighbor. We have 2 interfaces. We want also to migrate the service. And we also have a multicast service. I didn't put all the possible services because otherwise this demo would last, I don't know, 10 minutes, something like that. And now it's time to switch to my laptop. I haven't done it before. I hope everything works smoothly. Let me see. OK. I would like to mirror. OK, cool. So let's start. Let me initialize the demo. So here, while we're waiting for the initialization, I have a log, so I can show you something. So I'm resetting the NetSim devices. I'm bringing everything back to the initial state that I showed you in the slide. We're going to use the shell, of course, no graphical interface. And even better, I have prepared a few bash wrapper, so it's faster. Basically, I'm just echoing commands into the NSC CLI process. OK, so as I told you, I have prepared a few commands. Here is exactly the same situation as in the slide. Now I can start the categorization. So, 1, categorization. Here, I am running Revolution Migration, DevDays, Access Device, Migration, Start Categorization Slateless, and I get 3 categories, L2 VPN, Local Connect, and Multicast, as expected. And I just want to show you the same decision tree I showed you before. Here, for example, I ask myself, is the sub-interface 3, 5, 7, 8 under any P2P group? No. So this is not a P2P-related service. Let's find out if this is under a bridge domain. Again, no. And in this case, this 3578 is actually a multicast service. And in fact, now if we go back to our CDB, let's see what's inside. This is exactly what I told you before. okay, I understood the stateless service 22 is an L2 VPN, but it's not only that. Do you remember? I have also extracted a set of parameters from these expat queries that I have executed. Because anyway, I should redo it again now that I have to migrate. So let's do it once. And I have to find out, for example, what is the host name of the hub, because in the configuration I only have the IP address. So this is the time to get all the parameters that I need to do the migration. And of course, service 170 is a local connect. It's different. I don't have any neighbor. I have two interfaces, stuff like that. And 3578 is a multicast service. Perfect. We are ready to migrate. If you remember, we have two stages, pre-migration, cable swap. In this example, in the pre-migration, I don't touch the local connect services because it's impossible to do a redundant configuration in this case, so I have to wait for the actual cable swap. And okay, so basically here I have asked my Python package to pre-migrate sub-interface 22, and so the L2 VPN and the local and the multicast. They are migrated. Let me show you the dry run a little bit. As you can see here, I am modifying the configuration on the local aggregator. So I'm bringing everything on the local aggregator. Here, this is the hub. This is exactly what I told you before. I'm removing the old primary pivot over the feeder and creating a new one to a local aggregator with a backup neighbor and so on. And just to conclude the demo, let me trigger the final stage, which is the cable swap. In this case, in the cable swap, I'm migrating the local connect. If you want to know if you're interested about the details, I'm basically putting a pseudo wire between the feeder and the local aggregator in order to make the two interfaces communicate to each other. And this is exactly what I did. See, for example, this is a local aggregator. I'm bringing the sub interface, and this is an L2 VPN service, basically. But the pseudo wire is toward the feeder, because the other interface is still there. Now we can clean everything. This is the last stage. Cleaning means delete what is useless now. And for example, here, let me show you. This is the feeder. We delete everything. All these hub interfaces, the XConnect group, the IGP group, stuff like that. And this concludes my demo. And we can get to the conclusion slide. I can do it from here. I guess it's the same if it's not a problem for you. Okay, so we showed that, no, this is not really good. So preferably we can switch back to the original presentation. Okay, cool. Okay, so we showed you an approach for migrating services. Of course, stateful migration would be the ideal approach, but the real-world scenario has several challenges, and in the end, we needed a different approach. A different approach that works both for migrating services that don't have a service model, but also as a fallback mechanism for those stateful services that are corrupted somehow. Configurations are migrated with action handlers, either via translation templates or magic copy and replace. This approach showed you several benefits, and it's totally interoperable with the stateful approach, and it's still currently used in Telecom Italia production network. And that's all.
Oh, thanks, Marco.
You're welcome.
So let's put the Slido up for questions. But before we get to this, so I'm just trying to figure, it's interesting, this presentation and the previous one both kind of had two different approaches with the same problem.
Same problem, yeah.
Right? And I would think,
also yesterday's presentation,
I would think that you would accept, like, take the pill and say, you know what, we have to just get everything standardized with this, with a set of service models, and structure everything for the long term. That would be kind of the way to go. But both of you guys took a different approach where you just try to get the so that's interesting. So what do you lose by not having a service, though? I mean, if this, when this customer, decommissions, aren't you going to have a lot of dangling configs both on the hub and the spoke? You're going to have to figure out some process to keep track of that and clean up manually, right?
No, but in fact, that's a good question, of course. If you have a stateful service instance, eventually you need to reconcile the stateful instance. The point is that when do you want to do it? during the migration, which is a really stressful situation, trust me, or probably after. By the way, if the service is corrupted, it means that we haven't received any modify on the service. Nobody realized that the service was not in sync, you know? So what I'm saying is that even if you have instances, when is the best moment to reconcile a service? That's my question. So for when you have instances, you need then to realign the service instance.
Right.
Of course, and otherwise you break everything. Because the OSSs will interact with the
Right,
service through NSO.
So that's a good point. Do you want to reconcile, do you want to run some kind of a dry run ahead of time and find all the services that have issues and fix them first, or do you want to just get the customer up and running and then do it at a later time?
It's more time critical to migrate the service than reconcile the service.
So when you actually activate this switchover via the config, you have the guy switch the cable at the same time. So how much outage did the customer have?
Yeah, exactly like that. They do the pre-migration, they don't move the cable, they move the cable and they start the cable swap, which is really faster because a few services are touched by the cable swap. It's a real detail.
So one question, and then we'll move on. Stefan said, I see that both approaches you discussed are currently interoperating in your solution. However, if someone was to implement a similar use case from scratch, when would the stateless approach be?
Okay, that's a nice question. So we don't have a rule of thumb here. It really depends on the particular operation scenario. But I can say, if this were a real greenfield environment, probably I wouldn't waste time on implementing a stateless approach. In other cases, I would really use this because, as I told you before, it's also a fallback mechanism for migrating stateful instances. And if you do that from scratch, from the beginning, if you thought about your application and you already know that I want both approaches, you waste less time than we did because we didn't thought about that.
Right. Okay, great. Thank you, Marco.
Thank you.
Thank you, Marco.
Thank you very much.